This next video is going to discuss what we call polynomial synthetic division. And when we're talking about synthetic division, this is a shortcut that only works when my divisor is linear. So the divisor has to be linear. And it's a linear binomial, which means it only has two terms. And so an example of that would be something like x minus 1 or x plus 5. Something like this where you have a single x. And you always want the x to be a 1 in the front of the coefficient, for the coefficient as a matter of fact. If it's not a 1, you're going to have to go ahead and do synthetic. You're going to have to go back and do long division for it. So the process is called synthetic because it mimics the actual polynomial long division using shortcuts. So here's what we do it. We first take our, remember, this is the dividend. And this is the divisor. And we want our divisor to be linear. And here's linear. And we have x minus 1. So what we do is we create this thing that we call a shelf. And on the shelf, we take whatever the opposite sign of the divisor's number is. So you see, you have this -1. On the shelf, we're going to put a +1. And then what we're going to do next is we're going to make sure that this is written in standard form or in descending order. And from there, we're going to list out all of the coefficients in order. And we need to be careful that if we're missing terms, such as, and this one misses the x squared term, we put a 0 in its spot. So my coefficients are going to be 5 for the x cubed term, 0 for the x squared term, 6 for the x term, and then an 8. And so what we do next is we draw a line, and we're going to always bring this first term down. And here's what happens. Anything above the line, we're going to add. And anything below the line, we're going to multiply. So notice that this 5 is below the line. So we'll take this 5 and multiply by what's on the shelf. So it's 1 times 5 is 5. And that goes here. Since this is above the line now, we're going to do 0 plus 5. That's another 5. And then we'll go 1 times 5 again. This is another 5. And again, because it's above the line, we're going to add. So this is 6 plus 5 is 11. Then we'll go, whatever this back number is, whatever your last number is, we call it the remainder. So we'll go 1 times 11, because it's below the line, is 11. And we're going to add 8 plus 11, and that's 19. This right here is the remainder. Now, to write the quotient, you always write it 1 degree less than where you started. So notice here, we started at an x cubed term. If we write one exponent less than that, we're going to write this as 5x squared plus 5x plus 11 plus 19 over my divisor, which is x minus 1. And if you were to do long division with this problem, and let's do long division with this particular problem. Let's take the divisor x minus 1, and let's do long division with it real quick. And so we'll look at this as 5x cubed plus, there are no x squared, so I'll put a 0x squared in the spot, plus 6x plus 8. Remember what we do. We want to make this x look like that 5, so I'll multiply it by 5x squared. 5x squared times x is 5x cubed. 5x squared times 1 is a -5x squared. And so again, I'll change my signs. Minus, plus, cancels. 5x squared, bring these down. Right? So my next one says, again, make this x look like this 5x squared. So I need to multiply that by a 5x. 5x times x, 5x squared. 5x times -1, it's a -5x. So again, change your signs. Minus, that's a plus, cancels. 6x plus 5x is 11x. Bring this down. X will go into 11x, or x, make it like 11x. That is a plus 11. 11 times x, 11x. 11 times negative 1 is a negative 11. Again, change your signs, minus, plus. That's 19. This is the remainder, so we write our answer as 5x squared plus 5x plus 11 plus 19 over x minus 1, which is the same thing that we have sitting up here. So this is a shortcut. This method right here is a shortcut to all of this. And it works because the first thing we did was we made sure that this was linear, and then we put on our shelf, we put the opposite of this value, -1 changed to a +1, and we started adding. And that's because what you're doing is you're technically taking part of this, you're taking away the need to do this when you do that opposite sign. So let's do another one. Notice here, you have a linear term. And so we're going to write it out again. So we have on the shelf, this time we're going to put the opposite of a +2. That is a -2. And then we're going to list the coefficients out. In front of the x cubed is a 1. We're missing the x squared term, so we'll put a 0, -7, -6. Remember, above the line, we're going to add. Below the line, we're going to multiply. Bring the first one down. That's a 1. And we'll do -2 times 1 is a -2. 0 plus a -2 is -2. -2 times the -2, the +4. -7 plus 4, a -3. Whatever's in the back here is the remainder. So we'll do -2 times -3, a +6. -6 plus 6 is 0. Now remember, we started this at x cubed, x squared, x in the constant term. We always start 1 degree less. So we'll start it off with a x squared term here. So that's x squared minus 2x minus 3. And there is no remainder here. And this is going to be valuable to us when we start checking for zeros.